Android, Windows, Linux, iOS. You don't know what to do? Let's check it out. Hi, I'm Keith Szot, VP of Innovation and Solutions at Esper, and you're watching Fleet Geek. Build your dedicated device fleet your way. Hi, I'm Keith Szot, the VP of Innovation and Solutions at Esper, and today we're going to cover the OS choice for dedicated device fleets. I'm going to take you on a journey for a set of pragmatic considerations that we see from our prospects and customers when they decide on what OS they use to build their fleets off of. Come along. So let's first dive into hardware costs, what it costs for you to buy the devices. We're going to start out with iOS, meaning Apple. And so what you're going to get here is what I call prosumer. And so by definition, Apple is aiming for a more premium experience. And that's going to be reflected in the hardware and the costs that you pay. So as an example, at the floor, you have the iPhone SE, which is $329 to start. So for a phone, you're going to be going in at $329. Similar thing with the iPad. And then at the high end, you're going to be paying over $2,000 per device if that's what you want to deliver. So this is expensive. You don't have a lot of flexibility. It's set by Apple based on what they're trying to accomplish in the consumer market, and you have no alternatives if you go that route. You're beholden to them on what they're trying to do in the consumer world primarily. Now we'll jump down to Linux. And so Linux is interesting in that in the dedicated world, you can think of it as being driven kind of by the IoT market. That means you're going to have a lot of boards available for you, but not a lot of finished product or devices. There are a few of them out there, like I have a Pine phone. It's kind of cool to play with. It actually is relatively inexpensive, but this is more of tinkering and experimenting with end devices that humans work with. Of course, you have the PC space, but that is of a different ilk in terms of what our customers are typically trying to do with dedicated devices. We, of course, recommend Android for that with our operating system. But for this, the key point is that you have to figure it out yourself. You could get good economics around per device, but there's nothing really laid out for you here. You jump over to Windows. This is driven by the PC primarily. Yes, Microsoft does have some smart devices, if you will. You think of the Surface Duo line, but that is really, really expensive. And it really is an experiment to showcase Microsoft as a technology provider running on Android. So it really isn't an appropriate product for the dedicated device world. So if you're looking at PC as a form factor or as a compute, it could be interesting to look at Microsoft, but you have to remember two things. You are locking into x86, which is not necessarily a bad thing, but typically x86 has a slightly higher price point from a silicon perspective. But additionally, you're going to pay for the Windows licensing cost that is associated with this. And so you're going to have a higher base bill of materials for the hardware product that you buy. So it could fit into your use case, but you're also going to have to keep on paying because Microsoft is building an annuity stream off the OS with that. So that takes us to Android. Now the beauty of Android is the range. So with Android, you can go really cheap. We don't recommend it because the adage of you get what you pay for is true. I've dealt with $50 smartphones and they're not necessarily so good, but you can also get high-end product because in this ecosystem, the major players are competing against Apple. So they're trying to match the offerings at the high end. And so if you need to get a mix of dedicated devices where if you need a high-end device that runs Android, you can get it. The key part is the mid-range. And so the mid-range is getting you product between $100 and $200 per device that lets you kind of tune it to get the right price to performance that you're trying to achieve. This does not exist over in the Apple world. In finished product, you can't do it with Linux. That's not what the PC is about. You get that with Android. So that's why the range and the sweet spot of the middle is what Android delivers, which is perfect for dedicated device fleets. Another important factor is the longevity of the hardware, meaning the device model, can you purchase it 2 years from now? There's variability here depending on kind of what your use case is, your operational model, the solution that you're delivering, your use case, but it is an important consideration of what do you do. We see some customers that buy stock based on modeling breakage and fix and expansion to grab a model and keep it. But that is not necessarily the best way to do it because you have capital outlay associated with that. So let's do a review of the major operating systems and associated devices relative to that vector. So when you look at Apple, we know what they do. They are yearly. And each year, they're going to introduce the new models. And they're going to try to entice you to buy them because essentially Apple has a captured audience that their annuity stream is getting customers to buy new hardware. So you know that this is going to happen, and it also means that the older models are going to drop. And they're not going to be available anymore. And so if you standardize on a particular model at a price point, it's not going to work. So by definition with Apple, you're going to need to be able to keep pace with the new model introduction across iPhone and iPad on a yearly basis, which may be okay for you, but that's what it is. On the Linux side, it really is driven by the available hardware. So just like in terms of the hardware designs and the end products, you're going to need to keep pace with it. If you do a board, well, then you're going to need to make sure that you have board availability. It's not unusual in the IoT space. You're going to see more long-term delivery of hardware here because it is IoT, but it's going to be primarily around boards, not finished product. And so that is a limitation that for finished product, finished devices, it is kind of a wild and woolly place, and it's not really what the Linux market was designed for. Jumping over to Windows, again, this goes back to PCs. And so in the PC world, you have the PC refresh cycle. It's very much tied to the Intel and AMD silicon delivery, building out new designs. And so there definitely is a cycle here where you're not going to be able to get the hardware that's needed to be able to deliver your solution over time because it's going to refresh. Now, there is a carve out here that there are a lot of vertical market devices that are delivered from OEMs that do have longer support. But again, if you're getting the hardware, forget about Windows from that perspective because that's extra cost for you because you could do the same thing with Android with our Foundations operating system. And so that takes us to Android. So it is interesting to say that, you know what, Android has a lot of characteristics in the smartphone and the tablet space that you see over in the iOS world because these OEMs are competing with Apple. And so you do see a fast refresh cycle, but what we do see coming as a dynamic is kind of the blend of what you see with Windows in terms of these vertical market OEM products coming over to the Android space. So the Lenovo K10 is a great example, recently introduced. Lenovo is guaranteeing multi-year availability of the hardware. And so again, it goes back to if you want diversity and choice, you're going to get it over here. If you're happy keeping track with new introductions of the consumer tablet and smartphone space, you can get it. If you want something that has a little bit more longevity, you can do it with some of these commercially oriented smartphones and tablets that are being introduced by the major OEMs. And also too, if you go custom built, you have complete control because this goes back to the availability of the silicon for a long period of time. And you see that in the ARM world that's built around Android. And so that gives you complete control, and it really is a negotiation with your supplier for how long they're willing to manufacture and make the hardware available. So it kind of goes back to this is fixed, you know what it is. This is more IoT driven. You do have a lot of flexibility, but finished devices, much, much tougher. Over here, PC refresh cycle with the Windows cost. The best is Android, giving you the best of all the worlds of what you can do relative to hardware availability. The next is operational cost and flexibility. Interesting to say that there's not a lot of quantitative data out there around TCO in the dedicated device space, but we'll do our best to cover this, and a lot of it is based on my experiences of working with prospects and customers as they build their dedicated device fleets. So with Apple, you're going to have a high outlay in terms of purchasing the devices that we already talked about. But conceivably, it might be a smoother experience if you standardize on one particular model and you can deal with the product refresh cycle that Apple delivers. But no one has really studied this a little bit in the education market because that's a big place where Apple competes and plays. But suffice to say, my judgment based off this is that you're going to have a higher overall TCO primarily driven by the price point of the hardware that you bring in and the inability to effectively repair it that you see in the more closed Apple ecosystem. On the Linux side, it is, again, all over the map. So in a way, it's the beauty of Linux that, by the way, you get also through Android, that you have a lot of choice and flexibility here, and it really is about the supplier relationships that you have and the robustness of the hardware design that many times you own creating or tuning if you're going with a custom-built board. As far as like finished devices, this is a very thin market. So it leads to a question mark. You don't really know. How well will a Pine phone do out in the real world getting beat up for a dedicated use case? The data set really isn't there, so that means higher risk, and it's all on you to figure out. When you jump over to the Windows side, well, you're going to get something that is fairly well proven and studied for operational cost, right? Because it is Windows on PCs. But again, it's going to be more about the enterprise knowledge worker use case and less about how you roll them out in dedicated device fleets. I can tell you that based on how the PC architecture is set up and how it works with Windows, what we see is that when our customers move to Android on PCs, they do find a much better TCO and be able to leverage their existing capital outlay if they happen to go in with Windows running on these PCs by moving to Android. And so it is semi-flexible, where this is the least flexible with Apple. Linux gives you the ultimate flexibility, but you also get a lot of that with Android too. So again, it goes back to the best of all the worlds that you get with Android. So when you look at an operational cost perspective, it is driven by a lot your hardware choice. And so this part is up to you. And this is something that we at Esper can help with because we observe these devices. We work with customers that have them deployed. And again, there's a lot of range and variability that you can get here. So it really depends on what your business strategy is. Do you want to go low cost where you don't care about breakage and you'll just replace? Is your user experience driven by robustness and availability where you're willing to spend more for that initial hardware and you want a design that's going to keep operational over time? You can make those trade-offs here, which means more complexity, but more opportunity to tune it relative to what TCO you're trying to get and how flexible you want the system to be to tune it to your particular use case. So the clear winner for us is Android for this particular vector. Now we're going to talk about robustness, and this is from the perspective of the overall system. So this is the device with the hardware and the software together out in the real world. When you look at Apple, they're pretty good in terms of robustness. But it is a uniform delivery of robustness that doesn't really give you any choice to vary it. You have fixed form factor. It is for, again, the consumer design. So if it fits for what you're trying to do with overall, robustness of the hardware itself, droppage, screen breakage, those kind of things, then you'll be fine here. And then the overall system has relatively stable behavior based off of having so many users on iOS. It's not perfect, but it's pretty good in terms of what your expectations are. You will know what you're getting if you go the Apple iOS route. On the Linux side, again, kind of all over the map. It is IoT. Keep on writing on IoT for Linux. That's what drives it. So it does have to be very robust and resilient. But again, if you're trying to get a finished device, it will be a question mark because there's really not a lot of measure of those things out in the real world and what they can do. So if you're going to adapt a design, well, it could be very good if it comes from the IoT space, but it goes back to, well, why not Android? Because you can put it on that same hardware typically that you would put Linux on without the disadvantages of Linux. Going over to the Windows side, yeah, I gotta say it, the blue screen of death. We've all seen it. We kind of have some fun here where we post internal pictures of things in the wild with the BSOD for kiosk mode applications. And so you're gonna need to deal with that because Windows itself was designed a long time ago Of course, they've built on top of it to really improve it, and it does have some applications where it does need to be robust, such as on the server side. But when you're deploying out in the wild with field serviceability and the stability of the system, this can be kind of tough running on Windows, and there's really not a lot that you can do with it because it is a closed system with the Windows operating system to a large extent of what you get here. So just be aware of that downside, and it takes it to Android where, well, for Android, you can argue that it's not very robust. Well, except it is. Confusing, but that goes to the quality of the implementation. And what we mean by that is when you look at the major OEMs, they're going to have to deliver quality in both their hardware design as well as their implementation of the Android operating system on the device. And this is going to be driven by those dynamics of the consumer market competing against Apple. So it's a fairly good, nice bar to hit. But then once you get into more of the open space of the mid to low range, you do need to be careful because you can have some shoddily built operating system images that are put on these devices, as well as the hardware itself. So this is where you really need to do your due diligence. You need to test these devices to make sure that they fit. And you may want to go with the more well-known product, could be for a vertical market built on Android, could be from a major OEM, where you know that ruggedness has been tested sufficiently so that you're not going in blind as to what you will get here. So that's an important factor. A lot of choice, but also a lot of variability. Next, let's talk about security. So it's interesting with Apple and iOS. You can argue that they're strong from the security perspective, right? 6 to 7 years of patches that they typically provide for a model, leading in the industry. The thing about iOS, though, is that it is very much around the consumer use case. And based off of the focus of attacking iOS, what you're getting is a lack of transparency from Apple. And so if you're okay with that, then you might find that iOS is good for you from a security perspective. You know what you're going to get in terms of lifespan. You're going to get those patches delivered. You can fit into their ecosystem so that way you can be in the flow of these releases before they come out. Every once in a while there's a bad one and it gets patched and there's really nothing that you can do to prepare for it. But that's true for all these different operating systems. So a fairly good, strong security story, but it is within the Apple bubble if you're okay with that. On a Linux side, the Linux kernel is the strongest kernel imaginable from the perspective of it's open source, and it is used by governments. It is strengthened through the open source community. And so with Linux, you can argue that based off of this model and the openness with it, you're going to be able to deal with your security issues quite well. And if you set it up right, you can actually deliver the support yourself if you take ownership of the operating system. But it does mean that you basically have to follow the community, be a part of it to participate, which means that you're burning your engineers on this, which you may not necessarily want to do. On the Windows side, well, they try. And they have to try because they have all these enterprise deployments that they go into. But it is complicated. You know, I was just reading that for Windows 11, it takes 8 hours of leaving your system on in order to make sure that you can get Windows Update to cover things including security patches on your PCs. And so they're going to do just good enough to fit into the enterprise use case where if that's good enough for you and you can handle these wide parameters associated with keeping your devices safe through Microsoft, it may work for you. And that takes us to the Android world. And so it is a bit complicated here because you have different categories of classes of devices. Now let me just say that Google does a fantastic job here, where on a monthly basis they drop those security patches. And those security patches, since it's based on the Linux kernel, can also incorporate the great security work done in the Linux community that then Google takes and drops for the last 4 operating system versions that Google has put out in the market, approximately, right? So Android 12 going back to kind of Android 9 right now. As they move to Android 13, you're going to get that from Google. The key part though is how does this get delivered to the devices? And so that is up to the manufacturer of incorporating these fixes. First of all, they have to have an operating system release that they support on the device that is within what Google is providing to patch it. And then secondly, it is driven, if it's a GMS device, by what Google is trying to accomplish in the consumer market to work with OEMs to get the updates out there to the devices, which by the way is predicated by having an update service built into the operating system to accomplish this. For GMS devices, you typically are going to see that because Google requires it, but if you go out into the custom built, it kind of is up to you to make sure that that is there. So the key point is you really have to do your homework to understand for the particular piece of hardware that you're buying with the Android operating system, what exactly are you getting with security? It could be really, really good, on par or superior to what you get with iOS and Apple because you're dealing with the Linux community, or it could be really bad where it's an older Android OS version that has known vulnerabilities and you're not going to get an update or a patch for that ever, making it worse than Windows. So this is one that we like to help our customers and prospects out and figure out what they need to do because you can achieve very high security. We've seen some great use cases that require high security that successfully use Android, but you can also put yourself in a compromised position as well if you don't know what you're doing and you don't do your due diligence before you pick your device with your operating system on Android. So familiarity is next, and what we mean by that is how familiar our end users of the dedicated device are with the user experience paradigm. So this goes to how quickly can the user connect with it, understand it in order to use it for that particular use case. So it's interesting that with iOS, this is key about demographics. So part of it is, well, how many people are using iOS devices? And so if you look at market share, iOS is about 30% of these smart devices, smartphones, and tablets worldwide. So by definition, that means you're in a minority use case situation. So it is tied to region, and it is tied to particular demographics that you want to reach. I'll give you an example of a company that we were talking to that's very high-end clientele. For them, they want iOS only because that particular echelon, that slice of people that live in the United States through their research primarily use iOS devices. They're used to it, they're comfortable with it, so for them it made sense to go iOS. But the other side of this coin is about 70% of the devices used in the world are Android. So if you want to reach the masses, it's pretty obvious what you need to do. That takes us down to Linux, because with Linux you pretty much have to build your own UI. And this could be good if you have a very peculiar use case, and so it's kind of a fringy thing where if you need complete control over your UI for what you're trying to create on that screen to interact with the user, Linux may be the better choice for you, but very few normal humans know Linux and the UI in terms of encountering it and working with it. So if you're doing some kind of consumer-facing or employee-facing dedicated device use case, this is not going to work very well, and the work is going to be completely on you to figure it out, to how to make it map to these other UI paradigms that perhaps people know and are more familiar with. On the Windows side, you know, for better or for worse, people are becoming less familiar with the Windows UI over time. It's kind of something that you do at your job, maybe, if you're a knowledge worker. If you're a younger person, you may have never encountered Windows before as a UI. So that's a very important consideration, that this used to be the de facto standard for interacting with a computer, but it really wasn't designed for touch, and people are not familiar with how Windows works in the UI paradigm. That brings us to Android. You know, you have billions, literally billions of humans using Android across the world. If you look at doing something for an employee-facing device, the typical user coming in is going to know the Android paradigm and feel very comfortable in terms of using it. If you're talking about iOS users, it's close enough in terms of what you get through Android, because it is designed by definition for touch on these smart devices. And so you're going to get, in a sense, the best of both worlds here, where you can attract to the iOS users to the extent that you need to, and that most humans know Android in the world. So this makes the most sense. This is fading, this is specialized, and this is premium. This is where you want to be if you want the most humans to understand your use case. Next is technology with a particular angle on it. Let me take you through it. So if you're okay with proprietary, then you're okay with Apple, because that's essentially what Apple is. I mean, now you have the A-star processor line, the M-star processor line. They're building their own processors. They have their proprietary Lightning connector that's still around. Yes, USB-C is coming. But the point being is that you're going to be beholden to decisions that they make based on optimizing for their prosumer high-end market. So again, if you're okay with basically having to follow them for what they do from a technology perspective, hardware design, interconnect, cabling, processor, you could be okay here, but you have to realize that's what you're going to get. On a Linux side, you have everything is available to you really, because essentially you're dealing with the IoT world. And again, you're going to get that IoT focus over on the Linux side, but the underpinnings for it can be designed for whatever kind of custom device that you want to build. But you know, it goes back to the same thing. If you do that, you're going to have to bear those engineering costs yourself, because you are doing it and you're not going to benefit from all the activity being done by device makers, component makers, targeting the larger consumer and enterprise markets. So jumping over to Windows, you're on the x86 train primarily. Yeah, there's a little ARM there. Maybe I should do like a mini ARM, if you can see it. But with that, you're going to hit the price points associated with x86, and the technology is going to be driven by Windows. And so Windows has been around for a long time. You could call it a creaky scaffolding that they're skinning up to try to make it more modern. But it's kind of reaching the end of the road for the overall code base and where the industry is going. So that's a tough statement to make. You could decide for yourself if you believe it, but Windows has been around a very long time. Now, so has Linux, but the difference is the open source community and the dynamicism around it that leads to Android. And so with Android, what you're going to get is flexibility around the technology set. Pretty much anything that you need, that you want to be able to build, you're going to be able to do. You're going to see the fight with Apple happening again on the consumer side, which is really good, which means a more open and pragmatic approach to what Apple makes proprietary, you're going to see come over on the Android side. Yes, there's some movement to making your own chip. Around that, you see Google doing that with the Pixel line, but it's still a very broad open market with the silicon vendors competing with designs. You have a lot more choice in terms of what you can get from finished hardware, as well as the plethora of components that you can build on if you want to go custom built, which basically can leverage that IoT market over on the Linux side running the Android OS. So that way you have choice, flexibility, scale, for whatever you want to build. I'll cap it off to say that if you're doing a dedicated device fleet, many times you have mixed use cases in there that require different hardware and different tuning of the operating system. Android is the best to have that variability out of any of these choices. And so if you want to standardize on one OS, you need to do Android. It is the best one for broad-based dedicated device fleets. So I do want to hit on the technology infrastructure that is built into these operating systems for you to be able to manipulate and manage device fleets that run these OSs. So this is where the term EMM comes to play, Enterprise Mobility Management. And so you look at Apple and they do have a set of EMM APIs, if I can spell that right, that you can operate off of which Google provides the same thing on their GMS devices with a set of EMM APIs that are very clean and nice for you to be able to work with, but they're really designed, again, for the enterprise use case. Now, on the Google side, we have adapted these EMM APIs to apply them for the dedicated use case. If you jump down to Linux, that kind of structured EMM API doesn't exist. It can be built up and has been by MDM providers that cover the Linux space. And so you do have a path to get there. And in the same way, when you look at Microsoft, what they're doing is, again, doing EMM from the IT scenario. not necessarily optimized on dedicated. So when you kind of look at this, it's like, all right, these are all kind of equal. You can get it over here. But the difference with Android is they give you access to lower level controls that you can then apply across AOSP and GMS devices. So basically one pane of glass, regardless if it's a consumer device that is GMS or whether it's a custom-built AOSP device. This is what Esper takes advantage of to give you that fine-grained control and management of your devices. It also opens up further control from a DevOps perspective of how we can manage this driven by our cloud. So if you roll through it, EMM APIs, yes, you can get it over here. But Android gives you the advantage because they expose a lower level of technology set built into the operating system that allows you to execute on dedicated device fleet management scenarios. Let's talk infrastructure for apps. And what I mean by that is how do you manage apps that are distributed and installed to your fleet? Really important when you look at DevOps because a lot of it is driven by how do you manage your apps, your permutations of them to your dedicated device fleet in the field, in the real world. So let's start with iOS. So the thing about iOS is it really is all about the App Store. And that's what you're limited to. This goes back to that walled garden that they create where it needs to flow through App Store. Yes, you do have Test Flight, but it's designed specifically for that, for you to be able to test your app. And so with this, conceivably you can do DevOps through App Store, but it is much less fine-grained than what you would get if you have direct control over your app distribution. Now we'll jump over to Android now to compare where you have Google Play. And so with Google Play, there is managed Google Play that they provide, which is very fine infrastructure for being able to use it, especially with enterprise apps, of which there is an equivalent over on the App Store as well, for you to use Google's infrastructure to be able to manage your app load across your fleet. But the nice thing about what Google provides is that they give you the ability to directly work with the device fleet such that you can control outside of managed Google Play your apps. iOS is not going to let you do that. You need to stay within the walled garden, and so you're completely dependent on what iOS exposes for you to be able to manage your apps through device management, or MAM, mobile application management, kind of the industry term that's used as a substitute. When you look at Android, you get a ton of flexibility. Now you get the same flexibility over on Linux, super flexible, but again, you're kind of dependent on whatever infrastructure that was built for that particular Linux build from the supplier. Yes, it's kind of the same situation over here with managed Google Play, which by the way, this just runs on GMS devices. Over in the AOSP world, it's kind of saying that you're equivalent, that you're working with the same thing that you would get over in the Linux world. But the difference is, especially with Esper, is there's a lot of mature infrastructure that's provided. And in the case of Esper, we span both GMS and AOSP devices to give you what you need, that fine-grained control to do DevOps actions with your apps to your fleet. You know, I will touch on Windows. And again, Windows is more about the core IT scenarios. Yes, you can do dedicated device fleets on it, but it wasn't really designed for that purpose. So through Esper, we've been able to adapt our Esper Cloud with our app distribution installation infrastructure to tie it very tightly to the DevOps approach. You're not going to be able to easily do that through iOS. Conceivably, you can do it through Linux, but I would argue that it's harder to do. And then Windows, it really is about the old school scenarios for IT with PC desktops. Clear winner in this case, Android with Esper. Next, we'll cover user experience flexibility. So this is key of how do you design your use case with everything that you can bring to bear through the device and the OS to present the best experience for whoever is going to use your dedicated device. Now, let's start out with Apple and iOS. This is rigid. They're going to keep you in the lane, the box, however you want to call it, of the overall user experience spanning the UI, the OS, the hardware. As long as you're okay with Apple crafting and defining that box that you have to live in, it's okay. But if you want to go out of it, you can't. You're going to hit the wall, they're going to fight you, because that's not the design of your business. So you have to take that in consideration of how do you fit, and not only how do you fit today, but kind of map where Apple is going with this. You know, you think about the whole AirTag thing. Is that cool for you in terms of how Apple has to grind through to figure it out relative to your dedicated device use case? Kind of up to you. So you have to read the roadmap, you have to figure out your roadmap and see if that intersection continues over time, because you only have one road you're going to be on with Apple. On the Linux side, it is the ultimate flexibility, right? Which can be great, but that flexibility means you have to pay engineers to rigid it around the type of use case that you're trying to design. So it's almost just the opposite problem of like it's too flexible, and too much is on you to be able to build and figure out. So again, it always goes back to what is your use case, what are you trying to do, and if you really need to be able to tweak and tune it to the nth degree, Linux is the way to go. On the Windows side, it's pretty good. You know, the Windows UI gives you some good flexibility of what you can do. But again, it's designed for the old paradigm, which wasn't based on touch. So the pedigree of it is non-touch, and you're going to have to live with basically supporting the legacy path that Windows took and the path forward that Microsoft is going to take with the Windows platform, the uncertainty to what degree they're going to do smart devices, invest in ARM with Windows on ARM, things like that. And so this is kind of uncertain, but if you're fine with what core Windows provides, then it might be a good choice for you. So we jump up to Android, where Android is not as flexible as Linux, right? So not as much flex, but I call it Goldilocks in that you get good flexibility. It is a known user interface paradigm with lots of tooling for you to be able to tune and build the type of user experience that you want, with the hardware flexibility to create the kind of hardware that you want with a known quantity. Lots of developers know how to create applications with Android, which is different than the Linux world, which is more specialized. So this kind of balances things out where you can't do everything possible under the sun, but why do you need to? And from it, you're going to be able to build the right type of use case execution and not be stuck in the box, because with Android, especially with AOSP, you have the flexibility to be able to mold the operating system and the UI to deliver on your use case. So this is the worst for that. This is by far the best, but do you really want that, and do you want to pay for it? This is old. This is where you want to be for the modern world. I do want to talk about brand a bit more because it's an important consideration. The thing about doing an iOS device with Apple is that it really is about Apple's brand. And is that okay for you? Because it's going to smack through whatever dedicated device configuration that you deliver. And that may be okay. I actually see companies that view Apple as kind of a halo brand that they want to attach to. So they're okay with that, and they will move forward to feature Apple coming through it. But that means that you're giving up your brand to Apple, and that may be inappropriate for what you're trying to do. You know, kind of in the middle of the pack is Windows. You can hide some of the stuff, and it depends on your use case. Like if you're doing digital signage or something like that, arguably the end consumer of the content can't tell. But you get those episodes like the blue screen of death, right, where everybody knows it's a Windows device. And so it can come through, but it is more muted compared to Apple, which uses the industrial design of the device itself, which is very consistent to communicate the Apple brand. A little bit more variability, you can hide it with Windows, and so it's slightly better from that perspective. And then you get into Linux. And so Linux really is kind of unbranded and is a fertile playground for you to be able to shape and create your brand. But you have the disadvantages of Linux because really it is Android that is built on Linux, which gives you the ability to tweak and tune your brand experience based on the diversity of devices, your ability to commission devices to your specification and design language that you're trying to deliver. So really, it's like from a branding perspective, these are fairly equal, but you have to look at the technology stack to make that differentiated decision. So it's kind of up to you. Do you want to be part of the Apple halo? Do you want to go along with the Windows ride to the extent that they expose their brand experience through the OS? Or do you want to have full control over it and decide whether or not you want to take on the engineering burden associated with Linux, or you want to leverage the ecosystem that is made available to you through Android? Next, we're going to talk about developers and the developer pool. This is a very important consideration because the availability of technical developer talent to be able to build, roll out, and maintain your use case is an important consideration when you're building and maintaining your dedicated device fleet. So let's take a look at iOS first. And so it's pretty big. You see about 3 million developers worldwide. And again, data set, it's not really well followed these days, but this gives you a sense of where you sit. So that's not a bad pool of developers to have. And you have a couple million, I think it's like 2.2 million apps on the Apple App Store. So not too bad of a pool of apps to be able to pull from. So it looks kind of good, but again, you have to look at like what this is slanted towards, which is what Apple is trying to build with the ecosystem. And so I would say that it's kind of a limited developer pool, but pretty good in terms of what you're trying to get. On the Linux side, this is more, if you want to call it hardcore. Again, this is a lot by the IoT and the open source community pedigree that Linux has. And so there are a good amount of Linux developers. I say that out there because, believe it or not, it's not really well followed. So if you need to build a business case based on this being an aspect of justification, it's going to be tough to do because there really isn't a lot of data around this. So it kind of goes back to how easy is it for you to find and hire the kind of Linux developers that you need. But that's also the point, is that you're going to be paying developers to do things that arguably from these other platforms you're going to get built in or as part of the ecosystem. On the Windows side, this is like, it used to be Win32, right? That developer pool that's out there that arguably is fading. There's a ton of Windows apps. In fact, Microsoft argues that they have more apps on Windows than Android and iOS combined. But you have to look at what are those apps. And so you could be talking about like Lotus 1, 2, 3 being counted from the 80s and the 90s. So a little bit of skepticism there with that, because if you look at where things are going, the activity is up in the Android and the iOS space. And so that brings us up to Android. So here we're talking, based on the measure, 6 million developers worldwide. And that's a key point, is that you have a lot of diversity and choice of the markets where the developers are to bring that talent in. So a lot of flexibility that you have there, and you'll see that it is approximately double the amount of iOS developers. So that's a key point. Do you want twice the talent pool to be able to work with to build your use case in your app? You're going to get it with Android, and then through Play Store, we're talking about 3 million apps. So arguably like not that much better than the iOS side of it, but Play Store is the biggest and the most active in terms of applications, which means you have the ability to pluck these if you're doing a GMS device. And even if you're not doing a GMS device, those ISVs are out there to talk to negotiate or see if they have available their app to be able to put on your non-GMS device. So if you want broad availability of developer talent and the base availability of an application set to be able to put on your device, Android is the clear winner with this by far. Now we're going to talk about ecosystem, and this is ecosystem from the perspective of what set of companies, parties are available to you behind your use case that you can harness to your advantage to drive your business. So this is things like silicon vendors, component providers, companies that build the devices, going back to the software development talent as an example. So just to characterize it as a whole. So we'll start out with iOS and Apple, and my question is, what ecosystem, right? does it even have an ecosystem? Really, the ecosystem is a snow globe. Apple defines it, they own it, they control it. You really can't get to it. And so if you're happy with like the finished product they provide, then this may be a good choice for you, but it is a completely closed ecosystem. At the other end is Linux, which is wide open. It's great. There's so much you can do here, but it goes back to that theme of, okay, you may pay more money and burn your developers to be able to do this. And you also have to note that the core part of the ecosystem is based off of IoT use cases. Yes, you can adapt the stuff that's done on the PC side and bring it over for Linux, but it really is, well, if you happen to have an intersection of that IoT, it may be interesting, but again, that's Android, since it's based on Linux as well. When you go over to Microsoft, it is a more open ecosystem, but it is centered around Wintel. And you may not hear this term much anymore, but it really is, you know, x86 tied to the Windows OS. And that's what drives it. So more flexibility, more choice over here, but as long as you align with that agenda on the PC side primarily, then it could be good for you. But if you want the broadest, most flexible, that's where Android comes in. And it goes back to Google was brilliant with AOSP, and also their different programs like for TV, for auto, and also too, by the way, for tablet, again, yes, they're back and they see it. You're going to get like core-based designs and focus in the ecosystem that's driven by Google that then spills over to make it available for you because they're trying to monetize, they're trying to do business. And so this is very broad, very rich and robust, and basically gives you the ability to create whatever kind of solution that you want. And so it gives you the best of both worlds where it's not as wide open and focused on IoT as Linux, but you get the benefit of that because you can apply that activity up to your use case with Android. It's not locked in around kind of a stagnant use case for the PC side, but again, with Android on x86, you can do that. And it's definitely not a snow globe. So if you're into snow globes, hang out over here. If you want to do real world stuff with rich availability of what you can build off of in an ecosystem, it's Android all the way. So I want to cap it off with hardware diversity. And this is saying, well, what kind of hardware and designs can you get? Yes, it kind of bleeds into some of the other things that I talked about, but it's really, really important because that's all about the use case. That's what's different in our world with Esper and dedicated devices, is that the device itself is what delivers your use case and your experience. So it's really, really important. So it kind of goes back to, if you're happy with the fixed slots, so to speak, that Apple provides with their line, well, this could be good for you, but literally that's it. And if you haven't noticed lately, they're kind of the same between the iPhone and the iPad. There's not a lot of design language diversity and a lot of use case diversity, and really it's kind of a speeds and feeds differentiation that they do because they're going after like homogeneous consumer behavior because they're trying to repeatedly monetize a core base of humans. All right, if you're good with that and you want to build your business off of that, then iOS and Apple could be for you. That's not what we typically see in the vibrant, diverse community of dedicated devices of what customers are trying to do. On the Linux side, you know, it goes back to you can build what you want, whatever you want, but you kind of have to do it yourself, which means that the design requirements are on you, the engineering costs are on you, and you're not going to find a lot of finished off-the-shelf solutions that you can run with in this space. So keep on talking about Linux. It is kind of on the edge and the extreme. It's good for some particular use cases, but they're kind of fringy and leading edge and not necessarily the best if you're trying to build your business today off of dedicated devices. So when you look at the Windows PC world, what you're getting are pretty much driven by the PC form factor. Now, it's kind of funny because Microsoft is doing like some flexion show over here with the Surface Duo 2 being a good example. So you see some indicators of experimentation, but again, it's driven by Microsoft. It's not driven necessarily by the ecosystem as a whole because they're following the line of the PC to be able to deliver the type of innovation they want. You can get some interesting designs that come out of it, but it's things like laptops and desktops and servers are what is going to form and drive this particular industry. So it kind of goes back to, if it fits for you for what you're trying to do, fine. Now that takes you back up to Android, because yes, you have GMS that puts, kind of its own box around things for what the hardware design has to be. So the beauty of that, though, is that within that, there's a lot of differentiation and diversity through competition, primarily against Apple again, that you can get a lot of different type of smartphones and tablets. And they conform appropriately to GMS so that you do have some uniformity in terms of what's on the device, in terms of system capabilities, the OS itself, and the hardware definition of the products as well. But within that, it can flex a lot of different directions, giving you across price points for choice, as well as the hardware designs, a lot you can do. Now this is where it gets real interesting, because if you go AOSP, there is none of that box there. You can go wherever you want. And so that means that the benefit of what you can do in the Linux world is brought to you through AOSP, and it means you literally have millions of people, tens of thousands of companies that know how to do it based off the billions of devices that are built in the competition with Apple that you can take advantage of to build your specialized use case with the hardware and the software that runs on top of it that's unparalleled through any of these other more limited ecosystems. So hardware diversity, hardware choice, the ability to get it done, that is Android all the way. I stare because AOSP versus GMS, deep topic. We're going to dive into that in another video, so hold on to that thought about this, and we're going to go deeper into it. So to wrap it up, it goes back to, if you're okay with rigid and expensive, if it fits your use case, then hey, maybe iOS is for you. We don't see a lot of that because we work with more dynamic use cases and customers and prospects. If you're on the edge, and I mean not edge devices necessarily, but more on the leading edge of designs, if you want to call it fringe, whatever you want to term it, and you're willing to spend the money to do that NRE, non-recoverable engineering that's associated with it, and build it yourself, and also too, maybe if you're in the IoT space, Linux is a good choice. If you want to go old school and perhaps be a little stale with what you're doing with an old paradigm, and you're willing to take advantage of x86, then Windows might be what you want. But if you want the most dynamic, broad, vibrant ecosystem available to you to have choice and range for the type of dedicated device solutions that you build, it is all about Android. And as Andy would say, and by the way, good friends with Andy myself, Android is the way to go for dedicated device fleets, and you should run it using Esper. Thank you.